are going to talk about now is H parameter model. Okay, and since in your syllabus it's mentioned H parameter model for a transistor, we are going to do that. Okay, so H parameter model might be for any kind of two-port network. Okay, but we are going to just do it for transistors as of now. Okay, so H actually stands for the term hybrid. Hybrid. Okay, so it's basically a mix of impedance, admittance, okay, and so on. We're going to just look into that in more details later, okay. But then few points that we need to note is number one, we can actually consider it for a two-port network. So the question is, what exactly do I mean by two-port network? And probably for that, I can draw a very simple diagram and something about which you already know. Okay, so let's take the example of transformers. Okay, not the movie but the device. So let's just take this example here. So what happens usually in transformers, I'm not just going to draw the circuit in detail, okay, just I'm going to draw this. So let's say we have the transformer here, okay, and then we have got two windings of the transformer. If you remember, we have got the primary winding and the secondary winding. Okay, so let's say if I just want to draw it, let's say this is your primary winding, and might be the number of windings are less on the primary side, and this is the secondary winding. So secondary winding might be more. So if the secondary winding is more, the primary winding is less, we are talking about a step up transformer. Okay, the work of a transformer is actually to amplify the voltage, so increase the voltage or decrease the voltage, right? So this is the input, and we basically call it as the primary, right? So we already know about this. And if you look into this, this is actually the secondary part, right? So what are the parameters that we should actually know about a transformer, okay, in general? The first thing would be the voltage at the primary. So let's say we'll denote it with VP. Okay, and then we have got the current. Let's say this is IP. Okay, on the outer part, we basically can connect a load resistance. Okay, and we can actually find out what is the voltage across resistance, and we basically call it as the secondary voltage. Okay, and then we basically have the secondary current. So we have got the secondary current. So you see on the input, we have got two parameters, the current and the voltage. On the output, we have got two parameters, the current and the voltage. Okay, and that's the reason it is basically called a two-port network. Okay, so if you just think about a transistor, that also does the same thing. It is basically a two-port network. Okay, so we basically have got two parameters. Okay, two parameters in the input and output. In the input and output. Right, so you basically have got this. Okay, hence it's a two-port network. Hence two-port network. So first thing to understand is what is the two-port network, and this is what we mean by a two-port network. So in transistor also same. If you remember the input characteristics and the output characteristics, we are plotting the graph between the voltage and the current. So that is actually a two-port network. Okay, one more thing I'd like to explain before we actually go into that. If you remember, when we look into the input characteristics, we say it's the graph between the input current in the input voltage at a constant output voltage. Okay, so that means whatever parameter you're going to get will actually depend on the output voltage. So that is actually called a dependent source. So whenever we draw a dependent source, it is something like this. Okay, so this is something which you might have already learned before, but this is something which I need to tell you before we start. This is a dependent voltage source. Okay, so this is a dependent voltage source. Okay, on the other hand, if I want to draw a dependent current source, what I can do is I can just put an arrow here. Okay, and put an arrow here. This is a dependent current source. Dependent current source. So please remember this. Okay, this is the notation that is usually used. Some books doesn't really use it. Okay, some books do, but mostly you should use it. Okay, because you know, if you want to find out the input characteristics and you actually draw a current graph between the input current, that is base current, let's say, versus the, let's say, the base emitter voltage. Okay, you're basically going to draw it at a constant collector emitter voltage VCE. That is how the input characteristics is drawn, and you get a diode kind of graph. Similarly for the output characteristics also. So these are all nothing but dependent sources. So you basically show it in this way. Okay? So this is important. Okay. So now what we are going to do is we are going to talk about the H parameter for a transistor. Okay, for CE configuration. So H parameter for CE configuration. Okay. So if you actually want to do it, what you do is basically this. You are just going to draw the diagram first. So what I'm going to do is I'm going to draw the diagram today, okay, and tomorrow we are going to analyze the circuit, okay. So just look into it. If you want to practice, just practice it. I'm just going to show you how to draw it and remember it. I don't know if there is a trouble for you in this, but for me, when I was doing my MSc and even during my BSc, drawing circuit diagram was a nightmare, okay. So now I do realize that knowing the technique for drawing a circuit diagram is very important, okay? And that is why I'm just trying to do this for you, okay? So what you do is basically, since we are talking about a common emitter configuration, at these points at the bottom, it will be all emitter here. So this is an emitter, okay? We'll basically need 4 points here. So let me just draw 4 points. One emitter here. Let's say I'll put one more here, okay? And then this is also an emitter point. There is only one emitter, but I'm saying that the common points are 4. So there are 4 common points at which there will be a connection. Okay. So just let's look into the input part now. Okay. So this part will actually form the input, and this part will actually form the output. Okay. So first you draw this line and write down E on everywhere. Okay. And then what you can do, you can actually draw the input circuit. So you know, if a practical circuit we are talking about, we are going to talk more or less about uh, circuit which will have resistances and all. Okay, so we basically have a resistance here. Okay, so I take this, and you know, you want to measure what is the input voltage, so you basically have a voltage source here, but then that voltage source will be more or less a dependent source. Okay, so what you do first is draw the input part. Okay, so in input part, let me just draw this, and let me just draw freehand. Okay, and then I will measure the voltage. So I will draw a voltage source, and as I told you, it's a dependent voltage source, so I'll do this. So I'll just put a plus and a minus, okay? So that is also important, okay? And then we have got an input current. So since it's a common emitter, the current input will be nothing but the base current. So this is IB, okay? And if you want to have the voltage across this would be nothing but VB. The question is why it is VB, because the emitter is grounded. Okay, you have to assume this is already there. You can actually draw it also. The emitter is grounded, so that means this is at zero potential, and this is at the potential V. Okay, VB, the base potential. So that means we can just represent it as VB. Okay, and so this is the voltage source. Okay, so I'm not naming them, I'm just naming them later. Okay, when I explain it. Okay, so let me just draw this. So this is the input part that you have to draw. Okay, the circuit is kind of a bit different for knowing the each parameters, and then we are going to do the output part. Okay, so let me just draw the output part here. So I'm just doing it slow so that you all can understand it, and then we can use it later. Okay, and then you basically draw it here. Okay, and then the output you are going to take across a resistor. So I'll just draw a resistor here across a load, and we are going to see that this is not resistance but admittance later on. Okay, so let me just draw the current source here. So this will be the current source. Okay, so this is, so this is the current source that we have. Okay, and then we actually have a resistance here. Okay, so we have the resistance here, okay, and this is the current source that we have, okay. Let me just write down the other parameters that are there, which we already know, okay. So we have IC, the collector current, okay, and then we have got VC here, the voltage across the collector, right? And what we have is the collector at this end, okay, at the output terminal, and we have got the base at this end, so I'll write down B. So this is the base at this end, the input. At the output, we have got the collector. This is the collector current, okay? And then we are going to just write down the parameters now, okay? So we're just going to write down the parameters. So what you do here is, all these are H parameters. So I'll just write down H here. We'll slowly understand what are these. I'll also write down an H here for this. I can also write down an H here for this. And I'm going to write down an H here for this, okay? So this is how you draw the circuit and try to remember it, okay? I will put an I here, okay? I will put R here, R, okay? And then I will put a F here, okay? And I will put a O here. Okay, so please see this IRFO. Please remember it in sequence, okay? So that when you draw it, it will be more easy for you. Why it is R, why it is R, why it is F, why it is O, it is something which I'm going to explain tomorrow, but you write it down as IRFO. So IRFO, okay? This circuit itself will carry around 3 marks, so you have to draw it properly. And then since we're talking about a common emitter configuration, I'll just put IE here, I'll put a E here, I will put a E here, I will put a E here. Okay, so we have this H parameters. Okay, one more thing I'd like to add is that this particular voltage that you are going to get is going to be at a constant value of VC. Okay, so I will put a VC here. We will understand it when we analyze the circuit. Okay, and this HFE, the current that we are going to get, it is at a constant base current. If you remember the output characteristic, we have seen that it is a constant base current. So this is something where we are going to multiply it with IB. And this actually completes the circuit, okay? So please remember, this is your circuit diagram. So if I ask you a question on each parameter, possibly I will ask you a descriptive question and you have to draw the circuit diagram first, and then only you can proceed with the analysis of the circuit. Okay, so this is the H parameter circuit for CE configuration of transistors. Okay, so let me just explain this again. You have to draw the input terminal and the input part and the output part separately. Okay, at the input part you have got the dependent voltage source, at the output part you have got the dependent current source. You just draw a resistance here, you put the voltage across this, okay, and you have the current IB. Okay, and then you draw a voltage source, but don't name it, you can name it later. And at the output you draw a current source, a parallel resistance, which is the load resistance that we have, okay, and then we have got IC and VC. Start naming them now. You can put I, R, F, O. So with the H parameters, I will be here. So this will be an H parameter, this will be an H parameter, this will be an H parameter. Once you put this, we know it's a common emitter configuration, so I'll put a E here, E here, E here, E here. With the resistances, you don't need to do anything, just keep it as it is. But here we have the voltage source, which actually depends on the output voltage, as we have seen before. So we'll just put a VC here. Here, this will actually depend on the input current, that is IB, because we are talking about common emitter configuration. I will just multiply it with IB. And this is the circuit. And this circuit will actually have around 2 to 3 marks. And if you make a mistake there, probably you lose some marks. Okay, so please make sure you level them properly. Okay, it's important. And each of these terms has got some importance. Okay, I, R, F, O has got some meaning. Okay, so before we go into the next class, I'll just give you this information. I basically stands for input, R usually stands for reverse, F stands for forward, okay, and O, I think you can guess, it stands for output. And that's the reason it is being put. Okay, and tomorrow what we are going to see is Why it is called reverse, why it is called forward. I think input and output are quite obvious, okay? But then you will understand that this is actually not considered as resistance, this is considered as admittance, okay? So if you remember your basic electronics, you have got resistance R, okay? Some components that we already know, this is inductance, okay? And then we have got the capacitor, okay? So they have got a capacitance for the capacitor. So what usually happens is that this particular factor, when we talk about resistance, it does not depend on frequency, okay? But this actually depends, okay, on frequency. This is also depends on frequency. So any component which depends on frequency cannot be called as resistance. It will be basically called as impedance, okay? So this is also something which you are going to use tomorrow, okay? So we'll stop for today, okay?